So let's skip, I don't know what all that stuff is. Let's just go right to example 7 right off the bat. Mostly review today. I don't think there's anything new. It's just looking at these. One of the things that's really important in today's lesson, we're going to practice graphing, but another one is like describing transformations, like what are all those numbers and symbols doing to our graph. Another big important thing is being given information. Can we write the equation of that sine or cosine function? And then given a graph, can we pull enough information off that we know how to write the functions? It's actually pretty easy, okay? So starting with just a review of what we learned yesterday, which is phase shift, we can pull this information out of this function, right? Nobody gets amplitude wrong anymore unless you put a negative, no negatives. Remember, the period is period's the one thing in any of these functions that are not just a number you pull out. We know amplitude is A. In a minute, we'll talk about phase shift with this, which is C. If there's a vertical translation, that's D. And you just pull those numbers out and write them right down. Period is the only one that comes from the function, but it's not exactly that number. It's the period and B are related, right? We have to do a little math anytime we go between B or period, okay? So you guys know period is 2 pi divided by B, right? So pi. And then our phase shift, what direction are we going to go with this phase shift, guys? Left. Yep, left 3 pi over 2. Remember, that means that's our first point. That's the first point of our graph. Okay? So we are going to graph it. So our first point we know now is negative. Be careful. Left of 0 is what that means. Left of 0 is 3 pi over 2. So that's to the left 3 pi over 2. It's a cosine graph, so our first point would be up at 2, right? So we know our first point. And my advice to you is instead of trying to find all the middle ones, a lot of times if you just find your fifth point, the x-axis breaks up kind of naturally for you. But we'll talk about what to do if not. If we're at negative 3 pi over 2, which is right here, and we have to go out to out pi, how do you know how far to go? Like when we start at 0, it's really simple, right? We go out to pi, we use that much of the x-axis. Well, we're still going to use that much of the x-axis. So what do we do to our starting point to get to our fifth point? We add the period. Because remember, the period is the length of the x-axis. So if we start here and go out that length, you will have your final point. And it's really easy to change pi to any denominator because it's a 1 in front. And so that would just be 2 over 2, which gives you negative pi over 2. So our fifth point is right here, and it makes sense. Pi is a very short, scrunched together period. So this one is friendly, as I say. There's only 1, 2, 3 lines in between. We can easily break that up amongst our 3 remaining points, right? So remember the pattern of cosine. We start up and end up, but in the middle of that we have up, middle, down. I don't think I went up to 2, did I? Sorry. We should be up 1. I just can't see. Let's pretend we're up at 2. Right. Maybe I am. I can't even tell. All right, and then there. So then our graph would look like that. So if I did my first and my fifth point, so I have my first and fifth point, and they're really far apart, or the x-axis is all like a mess, maybe not broken up nicely for us, or we have a blank graph that we have to fill in. Remember, you can do midpoints. You could take your first and fifth point, add them together, divide by 2. That gives you your third point. That would have given you this one. And then if you take your first and your third point, add them together, divide by 2, you find your second point. And then if you take your third and your fifth point and add those together, divide by 2, you'd get your fourth point. So if you have to find 2, 3, and 4, you have a tool to do that, but try not to have to do that to save yourself some work. Okay? Question on that one? All right, we don't need to graph one. Let's list the transformations, okay? So in any order, somebody give me one. What's one of the transformations? Perfect, and I love that you said reflect. reflect over, and she said the proper axis. Okay, now the reason I'm giving her props for that is because the word reflect is like our math language, right? We easily, casually call it flipping and stuff like that, of course. I forgot, I have to take attendance in the first 15 minutes of class. Let me just really quickly do that. So it's not wrong to say flip. We know what that means. But it is better to say reflect, especially since we're trying to get into like that math language, varsity math language, I call it, for FRQs and stuff like that. So I know I've had some people ask me a lot of questions about the AP exam, and I'm trying to answer as best I can. But I will tell you, as we're getting closer, there's only 60-something days left, school days left till graduation. Can you believe that? And then, so our AP exam is just a couple days before graduation, right? So we're close. But as we get closer, we'll finish up the Unit 3 stuff, and all we're going to do is review, and I have some fun things to tell you about that I'm kind of excited about later. But I will be diving deep into any information I have about it. We're going to be doing practice tests that they create, talk about the do's and don'ts in the FRQ. So don't stress too much like, what if I put a flip instead of reflect? I'm going to tell you, try to use the better language, use show more work, those kinds of things on the FRQ. But I even read today that you don't have to ever graph one of these. You have to be able to identify them. So it sounds like you won't have to do one on your own. But when we get closer, I'll get all that stuff more clarified. Okay, so what else? What else is going on here? Anything? What? Oh, wait, that was you. Right 2 pi. Give me something else. Horizontal. Wait, let me write this one. Phase shift, or we could say, we could just say, you could say right 2 pi. You could say a horizontal translation to the right 2 pi. I think that was fine. What did you say? Dilation of 3. No. 2 in front. Let's go with that. That is, maybe you're thinking about that one. The 2 in front is a vertical, right? It goes up or down. Dilation, you could say stretch. Dilation means stretch or shrink, meaning compress, okay? It makes it taller or smaller by, usually we say factor of 2. So what the 3 does, 3 is kind of tricky. That's the only number that doesn't like exactly match when we put it in here. It affects the period. So that number I would explain as we have a period of 2 pi over the 3. So we're including the 3 in there because it does affect the graph. It transforms the graph from 2 pi to 2 pi over 3. Okay? So just being able to write those out, understand the math language is important. Okay? Good? Is that good, Hannah? You might have been saying something. All right. Let's practice. This is just one graph. I like practicing this graph with you because I feel like I haven't had a chance to do any midline graphs with you, and I've assigned them, so I want to make sure you guys understand them. So I'm going to start listing what they want. They want me to find the amplitude, the period, the midline. And they want me to graph this guy. Well, what else do I need to graph? Besides the amplitude and the period, which I get from A and B, there's the midline, that's D. There's no phase shift, so I'm not going to need that. But I do need nothing else. Forget it. That's the next problem. I've done that all day today. It's the next problem. I'll say that same sentence later. Okay, so we have an amplitude of 2, right, with a flip. It's a cosine graph, so normally we start up. This one's going to start down. The period, we know, is 2 pi divided by pi over 3, which is keep, change, flip, pi's cancel, period of 6. And since there's no phase shift, we get to start at 0. We have a midline. Remember, you get your midline from D. It's y equals 3. Middle. So let's do some things that we are really confident about. Since this is actually I'm not going to say it like that. Anytime you have a plus or minus out here, it changes where your x-axis is, right? All your points that you would have had graphed around the x-axis as your up, middle, down reference get moved up. So whenever you have a midline, start there and put that in. This is, now I'm going to think of as my new x-axis. So anything that's up will go above that. Anything that's down will go below that. Anything that's middle will be right on that line. Okay? So let's start. Since it's, again, cosine down, middle, up, middle, down because of the flip. So how far down from our new x-axis are we going to go? 2. So 1, 2. And we're starting at 0. We're also down, middle, up, middle, down. We're going to end down, and we're a period of 6. So I like to go ahead and fill that in. Then it makes it really simple to see where the other points are. In the middle of 0 and 6 would be 3, and that would be our up. So above 3 going up 2 would be at 5. And then we need our middles. So you could pick up your calculator if you needed to, but between 0 and 3 would be 1.5. Middle on my new x-axis. And between 3 and 6 would be 4.5. They should be equally spaced. And that is one period, 0 to 6. But they asked for us to go from 0 to 12. So we're just going to graph another period, exactly the same thing. Continuing on. This is my new first point. My last point would be at 12. First and fifth point there. In the middle of 6 and 12 would be 9. And then in the middle of these. So, forgive if I'm not perfect. But you see, like, you kind of start getting a feel for where all the points are. They have to be equally spaced. Sometimes you don't have to do a whole bunch of math. That doesn't look very good, but sometimes you don't have to do a lot of math. If you take a second and look at the x-axis, and I keep using that word friendly, this one was pretty friendly, right? We didn't have to sit over here and do a whole bunch of math. But notice how all my points moved up 3. A picture, we won't go through it. If there had been no plus 3, this same graph would have been around the x-axis exactly the same shape. Okay? Almost done. This is mostly what the homework is like. So, 2 examples, same directions. Write an equation. Write an equation that matches that stuff. Okay? And they're telling us this one's sine. And I'm only going to do one of them because cosine's the same exact thing. You just write COS instead of SIN. Okay? So let's go through what they gave us and identify what the variables are. Amplitude is A. Is period B? Period and B are not the same thing. That is super important. Remember I said, period and B, these are the ones that are kind of difficult. They make us do a little bit of math. A, C, and D are perfectly just right there. This is C, and if there had been a number there, it would be D. B comes from there, but it's not that. To find B, remember 2 pi always on top, divided by your period. Keep, change, flip. Pi's cancel. Our B is 3. We need B to write an equation. We need period to graph, right? Sorry. Did I do it wrong? Yeah. Go ahead. In that situation, it happens like that. Yeah. But what if that was 7 pi over 18, right? Okay. So I want you to have a way. I'm not making you show work for that, so you can see that. That's perfectly fine. Okay, so y equals, we have an amplitude of 3. We have a sine function. If we have a phase shift, we're going to put a bracket first. Brackets are just secondary parentheses. Can you do parentheses and parentheses? Yes, you can. It's just like more proper, whatever, to do this. B comes next, right? We just found B is 3. Then we'll put our phase shift. X, since we're going to the right, that's minus. Close my parentheses, close my brackets, and if there was a D, we'd put it here. And that would be your answer. So pretty simple, right? I'll do one in the homework with you too. So being able to write the equation from the given information. Now let's do our last one, which is writing an equation from a graph. Here's a graph. So we're going to do the same thing. We're going to pull information off. So things that we need are A, B, C, and D, really, right? We need an amplitude. We need a period. We'll be able to pull a period off of here. And from the period, of course, we'll get our B, just like in the last problem. Is there a midline? Yes, there is. Not always, right? We just did one that doesn't have a D. Midline and D are the same. And here's where what we're not going to do. We're not going to deal with a phase shift, because guess what? We get to find an equation for the graph. So we get to pick what this is. Are we going to call it sine? Are we going to call it cosine? Are we going to start at 0? Or are we going to start here and have a phase shift in our equation? Okay, and I'll show you what I mean once we're done. So anytime you get to find your own equation, it is so much easier to start at 0 and count 5 points. Okay, so if I start at 0 and count 5 points, all of a sudden I run into a problem, because that's what I jump in to do. I'm like, ooh, let's see what the period is, what the amplitude is, and you start by counting 5 points. The problem here is that our amplitude is not, well, the height above and below are not that same value. Like, if we were up at 5 and down at -5, our amplitude would be 5, midline would be y equals 0, but it's not like that. So that means there is a midline in here, and it's always where this x-intercept is. Look, that's going to split our graph in 2 equal parts. It is a line, right? Line. It's a horizontal line, and it is at 3. Guess what that does? Helps us find the amplitude. Whether you count it from here or here, from 3 to 5 is 2. Now I can count my 5 points, because the way it was drawn before, it looked like this was an up. Now it's a middle, right? This is middle, down, middle, up, middle. What type of graph is this? Sine or cosine? Sine with a what? Flip. Oh, I shouldn't have done that. Sorry. With a flip. Just got excited. This is a sine graph, and it goes middle down, middle up, middle. So that tells me I'm going to have to flip or make my amplitude negative, or put a negative in front, whatever. All right, and what's the period? 4 pi. So all we need now is what letter? B. How do you find B? 2 pi divided by the period. We're ready. Y equals, amplitude was 2 with a flip, sine, parentheses, don't need brackets, B is 1/2 times x, or theta, you could make that a theta if you wanted to, close them, and positive 3 plus 3, we moved all our points from the x-axis up 3. So that's the easiest way to do it. But the point is, you could have, watch. What if you're like, I don't want to. I want to start at this point. I like this point. So this is going to be my first point. 1, 2, 3, 4. You'd have to continue the graph. But if you did this is a sine graph that has a flip in it, right? Down, middle, cosine. Down, middle, up, middle, down. With a phase shift, right pi. So you'd have to build the phase shift in. Or you start here. What if you want to start here? That'd be middle, up, middle, down, middle, with a phase shift, right 2 pi. You can see, guys, because this goes on forever in both directions. You could have left phase shifts and any amount of right phase shifts, both directions. So that's why the answers may vary and are endless and infinite. We could all have different ones and be right. But why would we pick something different from 0? Why would we make it harder for ourselves? So whenever I have this choice, I'm like, nope, don't want that one in there. So I leave C out. By leaving C out, I'm starting at 0. It's just my choice. Does that make sense? Yes? Okay. Let's go to the homework. 1 through 7, 11 through 12. Ignore this stuff here. My notes look different than yours, so I had to fix something. But my 5 and 6 look different from yours, but they're the same problem. You should have no problem finishing this in class, guys. Baba, are you ready today to do it? You want to do it Monday? Okay. I'm sorry. I did move that kind of quickly. Sorry about that. It's always on the board too. Now that you guys are in front, it's always right here too. That's great. Alright, there's 7, 10, 11. And I'm going to put the homework check up, get that going. Just my day I waste trying to get this right. That's the best I can do. And it recorded. Hallelujah.